According to the National Electrical Code, NEC 2020, Section 314.17b, enclosures for conductors state conductors entering a box shall be protected from abrasion and shall be securely fastened to the box. Additionally, Section 314.17c addresses fittings stating fittings used for the protection of conductors and cables shall be approved for the purpose. A broken knockout coil on a plastic box can compromise the security of the wire entering the box. Firstly, the wire may be able to move around within the box, increasing the risk of damage. Secondly, the wire may be pulled out of the box, potentially creating a safety hazard. While the NEC does not specifically require that all KO be clamped, it implies that the wire entering the box should be securely fastened. Clamping the KO around the wire provides additional protection and helps prevent the wire from being pulled out. The inspector's interpretation that the wire should not be able to be pulled out of the box is reasonable, given the importance of securing the conductors. To resolve the issue, 1. Replace the broken KO with a new one, and 2. Install a wire clamp on the new KO to securely fasten the wire. While not explicitly stated in the NEC, it is generally recommended to clamp KO on plastic boxes to ensure the secure entry of wires and prevent potential safety hazards. Therefore, the National Electrical Code, in Section 314.17b, mandates that conductors entering an electrical box be protected from abrasion and securely fastened. This regulation aims to prevent damage to the wires and ensure a safe, reliable electrical connection. A broken knockout compromises the integrity of this protection. When a knockout is broken, it creates a gap or opening that can allow the wire to move excessively within the box. This movement can lead to abrasion against the edges of the knockout or other components inside the box, potentially damaging the insulation of the wire. Damaged insulation increases the risk of short circuits, ground faults, and electrical fires. Furthermore, a broken knockout weakens the physical security of the wire connection. Without a secure knockout, the wire is more susceptible to being pulled out of the box, especially if there is tension or stress on the wire. This can disconnect the wire from its terminals, leading to a loss of power and potentially exposing live wires, creating a significant safety hazard. Although the NEC does not explicitly state that all knockouts must be clamped, the requirement for secure fastening implies that measures should be taken to prevent the wire from being easily pulled out of the box. Clamping the knockout around the wire provides an additional layer of protection and ensures that the wire is securely held in place. This reduces the likelihood of the wire being accidentally pulled out or becoming disconnected due to vibration or other external forces. The inspector's interpretation that the wire should not be able to be pulled out of the box is a reasonable one, given the emphasis on safety and secure connections in electrical installations. Inspectors are responsible for ensuring that electrical systems meet the minimum safety standards outlined in the NEC and other applicable codes. Their interpretation is based on their experience and understanding of the potential hazards associated with loose or unsecured wires. To rectify a failed inspection due to a broken knockout, several steps can be taken. Firstly, the broken knockout should be replaced with a new one. This restores the structural integrity of the box and provides a secure entry point for the wire. Secondly, a wire clamp should be installed on the new knockout. The wire clamp provides a mechanical grip on the wire, preventing it from being pulled out of the box. The clamp should be properly sized for the gauge of the wire being used and securely tightened to ensure a firm hold. In conclusion, while the NEC may not explicitly mandate clamping all knockouts, it is generally recommended to do so, especially in situations where the knockout is broken or damaged. Clamping the knockout ensures the secure entry of wires, prevents potential safety hazards, and helps to ensure compliance with electrical codes and regulations. By taking these steps, you can address the inspector's concerns and ensure a safe and reliable electrical installation. This also involves understanding the broader context of electrical safety in residential wiring. The National Electrical Code, or NEC, serves as a cornerstone of safe electrical practices in the United States. It's a comprehensive set of standards designed to protect people and property from electrical hazards. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and refine existing regulations based on field experience and research. Adherence to the NEC is crucial for ensuring that electrical installations are safe, reliable, and compliant with legal requirements. Residential wiring encompasses all the electrical systems within a home, including the wiring for lighting, receptacles, appliances, and other electrical devices. Safe residential wiring is essential for preventing electrical shocks, fires, and other hazards. Proper installation, maintenance, and repair of residential wiring are critical for protecting the occupants of the home. The importance of secure wire connections in electrical boxes cannot be overstated. Electrical boxes serve as junction points for wires, providing a safe and organized way to connect electrical devices and appliances. Secure wire connections within these boxes are essential for ensuring a reliable electrical system and preventing potential hazards. Loose or improperly connected wires can cause a variety of problems, including intermittent power outages, flickering lights, and overheating of wires and devices. In extreme cases, loose connections can lead to electrical fires. Therefore, it is crucial to ensure that all wire connections within electrical boxes are properly made and securely fastened. Wire clamps play a vital role in securing wires within electrical boxes. These clamps are designed to grip the wires firmly, preventing them from being pulled out or becoming loose over time. Wire clamps come in a variety of styles and sizes to accommodate different types of wires and boxes. Some clamps are designed to be used with specific types of knockouts, while others are more universal in their application. When selecting wire clamps, it is important to choose the right size and type for the specific application. The clamp should be compatible with the type of wire being used and should provide a secure grip without damaging the insulation of the wire. Proper installation of wire clamps is also essential for ensuring their effectiveness. The clamp should be securely fastened to the box and tightened to the appropriate torque to prevent it from loosening over time. Regularly inspecting wire clamps and tightening them as needed can help to maintain the integrity of the electrical system and prevent potential hazards. Now let's delve deeper into the specific requirements outlined in NEC section 314.17. This section addresses the protection and support of conductors entering boxes, conduits, or fittings. It is divided into several subsections, each covering different aspects of wire management. Subsection 314.17 focuses on the protection of conductors from abrasion. It states that conductors entering a box, conduit, or fitting shall be protected from abrasion. This means that the edges of the opening through which the wires pass must be smooth and free of sharp edges that could damage the insulation of the wires. If the edges are not smooth, a bushing or fitting should be used to protect the wires from abrasion. Subsection 314.17b, as previously mentioned, requires that conductors entering a box be securely fastened to the box. This means that the wires must be held in place in such a way that they cannot be easily pulled out or become loose over time. Wire clamps are commonly used to meet this requirement. The clamp should be installed in accordance with the manufacturer's instructions and tightened to the appropriate torque to ensure a secure grip on the wires. Subsection 314.17c addresses the use of fittings for the protection of conductors and cables. It states that fittings used for the protection of conductors and cables shall be approved for the purpose. This means that the fittings must be listed or labeled by a recognized testing laboratory such as Underwriters Laboratories, all to ensure that they meet safety standards. The fittings should also be compatible with the type of wire or cable being used and should be installed in accordance with the manufacturer's instructions. In addition to these specific requirements, NEC section 314.17 also includes general requirements for the installation of boxes, conduits, and fittings. These requirements cover topics such as the size and type of box to be used, the spacing between boxes, and the support of boxes and conduits. Adhering to these general requirements is essential for ensuring a safe and reliable electrical installation. The role of electrical inspectors in enforcing the NEC is crucial for maintaining electrical safety. Electrical inspectors are responsible for reviewing electrical plans, inspecting electrical installations, and ensuring that they comply with the NEC and other applicable codes. Inspectors play a vital role in identifying potential hazards and ensuring that they are corrected before the electrical system is put into service. When an electrical inspector identifies a violation of the NEC, they will typically issue a notice of violation, which outlines the specific violations that must be corrected. The homeowner or contractor is then responsible for correcting the violations and scheduling a re-inspection. It is important to take notices of violations seriously and to correct the violations promptly. Failure to do so can result in fines, delays in construction, and potentially dangerous electrical conditions. Working with a qualified and licensed electrician can help to ensure that electrical installations comply with the NEC and that any violations identified by the inspector are corrected properly. Now let's discuss some best practices for preventing broken knockouts in electrical boxes. Broken knockouts are a common problem in electrical installations, and they can compromise the safety and reliability of the electrical system. There are several steps that can be taken to prevent broken knockouts. Firstly, use the proper tools for removing knockouts. Knockouts are designed to be removed using a knockout punch or a screwdriver and hammer. Avoid using excessive force or improper tools, as this can damage the box and break the knockout. Secondly, support the box when removing knockouts. When removing a knockout, it is important to support the box to prevent it from flexing or bending. This can be done by holding the box firmly with one hand while removing the knockout with the other. Thirdly, inspect the box for damage before installing it. Before installing an electrical box, inspect it for any signs of damage, such as cracks, dents, or broken knockouts. If the box is damaged, it should be replaced with a new one. Fourthly, use the correct size knockout for the wire or cable. When installing a wire or cable through a knockout, it is important to use the correct size knockout for the wire or cable. Using a knockout that is too small can damage the wire or cable, while using a knockout that is too large can create a gap that allows moisture and debris to enter the box. Fifthly, install wire clamps to secure the wires or cables. As previously mentioned, wire clamps play a vital role in securing wires and cables within electrical boxes. Installing wire clamps helps to prevent the wires or cables from being pulled out of the box and also protects them from abrasion. By following these best practices, you can help to prevent broken knockouts and ensure a safe and reliable electrical installation. Furthermore, consider the different types of wire clamps available for securing wires in electrical boxes. There are many different types of wire clamps available, each designed for specific applications. Some of the most common types of wire clamps include screw-on clamps, snap-in clamps, and compression clamps. Screw-on clamps are typically used for securing non-metallic sheet cable, NM cable, to electrical boxes. These clamps have a screw that tightens down on the cable, providing a secure grip. Snap-in clamps are often used for securing flexible metal conduit, FMC, or armored cable, AC, to electrical boxes. These clamps have a spring-loaded mechanism that snaps into place, providing a quick and easy way to secure the cable. Compression clamps are typically used for securing rigid metal conduit, RMC, or intermediate metal conduit, IMC, to electrical boxes. These clamps use a compression fitting to create a watertight seal between the conduit and the box. When selecting wire clamps, it is important to choose the right type for the specific application. The clamp should be compatible with the type of wire or cable being used and should provide a secure grip without damaging the insulation of the wire. Proper installation of wire clamps is also essential for ensuring their effectiveness. The clamp should be securely fastened to the box and tightened to the appropriate torque to prevent it from loosening over time. Regularly inspecting wire clamps and tightening them as needed can help to maintain the integrity of the electrical system and prevent potential hazards. In addition, think about the grounding requirements for electrical boxes and equipment. Grounding is an essential safety measure that helps to protect people from electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. All electrical boxes and equipment should be properly grounded in accordance with the NEC. The grounding conductor should be connected to the box or equipment using a grounding screw or other approved means. The grounding conductor should also be connected to the grounding electrode system, which typically consists of a ground rod or a metal water pipe. Proper grounding is essential for ensuring electrical safety. Failure to properly ground electrical boxes and equipment can increase the risk of electrical shock and fire. If you are not familiar with grounding requirements, it is best to consult with a qualified and licensed electrician. The concept of overcurrent protection is crucial for preventing electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds the rated capacity of the circuit, preventing the wires from overheating and potentially causing a fire. Circuit breakers are automatic switches that trip when the current exceeds the rated capacity of the circuit. Fuses are one-time devices that melt and break the circuit when the current exceeds the rated capacity. Both circuit breakers and fuses are essential for providing overcurrent protection. It is important to choose the right size overcurrent protection device for the circuit being protected. The overcurrent protection device should be rated to carry the normal load of the circuit, but it should also be able to trip or blow quickly in the event of an overload or short circuit. Regular inspection and testing of overcurrent protection devices can help to ensure that they are functioning properly and providing adequate protection. Also, consider the importance of proper wire sizing for electrical circuits. Proper wire sizing is essential for ensuring that electrical circuits can safely carry the intended load. The size of the wire determines its capacity, which is the amount of current that the wire can safely carry. If the wire is too small for the load, it can overheat and potentially cause a fire. The NEC provides tables that specify the minimum wire size for different types of circuits and loads. These tables take into account factors such as the type of insulation, the ambient temperature, and the number of current-carrying conductors in the raceway. It is important to consult these tables when sizing wires for electrical circuits. Using a wire that is too small can be dangerous, while using a wire that is too large is unnecessary and can add to the cost of the installation. Proper wire sizing is essential for ensuring a safe and reliable electrical system. Furthermore, let's discuss arc fault circuit interrupters (FSIs), which are life-saving devices designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended electrical discharge. These arc faults can generate intense heat which can ignite nearby combustible materials and cause a fire. FSIs are designed to detect these arc faults and quickly interrupt the flow of current, preventing a fire from starting. The NEC requires FSIs in many areas of the home, including bedrooms, living rooms, and dining rooms. FSIs are typically installed in the electrical panel and provide protection for the entire circuit. Regular testing of FSIs is recommended to ensure that they are functioning properly. To test an FSI, simply press the test button on the device. The FSI should trip and interrupt the flow of current. If the FSI does not trip, it should be replaced immediately. FSIs are an important safety device that can help to protect your home and family from electrical fires. And ground fault circuit interrupters (GFCIs) are another essential safety device designed to protect against electrical shock. GFCIs are designed to detect ground faults, which occur when current leaks from an electrical circuit to ground. These ground faults can be caused by damaged insulation, faulty equipment, or contact with water. GFCIs quickly interrupt the flow of current when a ground fault is detected, preventing electrical shock. The NEC requires GFCIs in many areas of the home, including bathrooms, kitchens, and outdoor locations. GFCIs are typically installed in receptacles of circuit breakers and provide protection for the individual outlet or the entire circuit. Regular testing of GFCIs is recommended to ensure that they are functioning properly. To test a GFCI receptacle, simply press the test button on the device. The GFCI should trip and interrupt the flow of current. If the GFCI does not trip, it should be replaced immediately. For GFCI circuit breakers, you can perform the same test using the test button on the breaker itself. GFCIs are an important safety device that can help to protect you and your family from electrical shock. When dealing with electrical work, personal protective equipment (PPE) is essential for ensuring your safety. Working with electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock, burns, and other hazards. PPE includes items such as safety glasses, rubber gloves, and insulated tools. Safety glasses protect your eyes from flying debris and other hazards. Rubber gloves provide insulation from electrical shock. Insulated tools are designed to prevent electrical current from flowing through your body. When working with electricity, it is important to wear the appropriate PPE and to follow safe work practices. Always de-energize the circuit before working on it, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electricity, it is best to consult with a qualified and licensed electrician. And finally, regular electrical maintenance and inspections are crucial for preventing problems. Regular electrical maintenance and inspections can help to identify potential problems before they become serious. Maintenance tasks include things such as tightening loose connections, inspecting wiring for damage, and testing safety devices. Inspections should be performed by a qualified and licensed electrician. The electrician will inspect the electrical system for any signs of damage, wear, or code violations. They will also test safety devices to ensure that they are functioning properly. Regular electrical maintenance and inspections can help to ensure a safe and reliable electrical system. They can also help to prevent costly repairs and downtime.